Hello everyone. Before moving further, uh, we will discuss the last lecture, or it is a kind of recapitulation before moving to the last numerical example of these Newton's backward difference formula, and or that example would also make use of the Newton's forward difference formula. So that we will learn in this lecture, that how to select which formula to use in the given condition. So firstly, we will recapitulate whatever we have studied in the last lecture, and it is a kind of regaining, or it is a kind of pacing yourself to learn the concept smoothly, thoroughly, and at the intellectual level. So we will again grasp the some basics idea that we have studied in the last lecture. By Newton backward difference formula, we know this formula is given by this one. So where P is x minus xn by h. This is Newton backward difference formula, and this formula is used when we have to interpolate the value which falls near the end of the table. Now Newton's backward difference table, this is these are the arguments, these are the values of the function at the arguments, and you know this one del y1, which is y1 minus y0. This is del y2, which is y2 minus y1, and similarly you complete the table. In forward difference, what we used to do, I would show you, we used to write over here. So I would show you here. So let me first make some, we used to write, let me change the color also. Color, I think black will be fine. We used to write delta f of x, and here since it was the forward, so we used to write y naught and in the forward direction, so forward with respect to y naught, so we used to write over here delta y naught. Rest of the thing was same, y1 minus y naught difference was same, and whenever we will be writing the table, we will be writing only difference, not notation. But if we write the notation, this is the difference in the backward with respect to 1, in the forward with respect to 0. So we will write forward with respect to 0, backward with respect to 1. This is del. Similarly, backward with respect to 2, forward with respect to 1. So if I write over here, so this will be delta forward with respect to y1. Okay. So that way you have to understand that this is the minor difference that you have to make while writing the Newton backward difference table in the notations uh, language. So that is the minor difference. So that is how you could complete it. This one is equal to, if you write it, you want to write this, which is del y2 y2 minus del y1. Okay, So this is the second order, and similarly you will write up to the fourth order. So that is how we had constructed the Newton's backward difference table. So now we'll be moving forward, and if we talk about the which value to pick, so you will pick from here, not this one. You will pick this value, you will pick the last value in the backward, you will pick this value, you will pick this value, you will pick this value. So these values you will pick from the end of the table. So that recapitulation is important in the sense, and this is the formula. Whichever will be written here will be put over here, whichever will be written here numerical value, that will go over here, whichever will be here, that will go over here, whichever will be here, that will go over here. And similarly we can write the fourth term also, which is p, close the braces, p plus 1, p plus 2. So you could generalize up to whatever terms you want based upon the demand of the question. P plus 2, p plus 3, so you could easily generalize p plus 3, this will enclose in the braces, divided by, it will be 4 factorial, and it will be del 4, and it will be y 4. Okay, so here up to nth order, because the n values were given in this, so we write yn, but now if 4 values are given, we write y4 everywhere. So this will be the next, and you know the way you can calculate the value of p, and then it will be substituted over here. So that is how we can calculate using the Newton's backward difference table, and then by using the Newton's backward formula. Now we'll moving towards the last example that will show us that how to discriminate between the Newton's forward difference formula and Newton's backward difference formula. So this is the next example we will be studying on backward difference formula. The population of the town is given below. Estimate the population for the year 1895 and 1930 using suitable interpolation. So in this numerical example, you will see 1895 is near to the this beginning of the table, and 1930 is near to the end of the table. So for this, I will discriminate between the Newton forward difference formula and Newton backward difference formula. If your value which is to be calculated lies near the beginning of the table, and if the value which is to be calculated lies near the end of the table, then you will use the, for the beginning you will use the forward difference formula, and for the end value you will use the backward difference formula. So firstly we will shall form the table, that is difference table. This is the population, first order, fine. second order, and you know how to make it. 66 minus 46 is 20, 81 minus 66 is 15, 93 minus 81 is 12, 101 minus 93 is 8. Similarly, this difference 15 minus 20 minus 5, 12 minus 15 minus 3, 8 minus 12 is minus 4. Similarly forms the third order. Minus 3 minus minus will be plus. Minus 3 plus 5 is 2. Minus 4 minus minus will be plus. Minus 4 plus 3 minus 1. Similarly minus 3. So this is the difference table. Now we'll see h here is this distance between the consecutive arguments, which is 10. X is equal to 1895 and x naught is equal to the initial value, because now we are going to use the Newton forward interpolation formula, and for that p is x minus x naught at 1895 minus 1891 by 10, which is 0.4. So we know by Newton forward interpolation formula, this is the formula. We have the value of p, we will put over here, here, and the various values that we will pick from the table. The initial value we will pick. So like if I show you, to pick in the forward difference formula, we will pick this value, the initial values. And what is the difference between forward and backward? For the backward difference formula, you will choose the pick the and values, like over here the and values will be picked up. Okay, and so these values are put over here. So this is when calculated gives 54.852. So this is the population of the given concerned problem in the Sun 1895. So that we have calculated using, we voluntarily have chosen this Newton's forward interpolation formula, because this was laying, it was up to us which formula to use. So we will find the suitable one. Suitable one is forward interpolation formula, because here this value 1895 is near to the beginning of the table. So this value is calculated based upon the Newton forward interpolation formula. So to calculate the population in the year 1895, we cannot use Newton backward interpolation formula, and that would be wrong choice, and you may lose the marks in the examination. So now 1930. End of the table is 1931. H is 10. P you know is x minus xn. The last one. 1931. So this will be minus 0.1. Now using Newton's backward interpolation formula, what will get? You know by this formula you have this thing, and you can generalize up to whatever order you need it. You need it up to fourth order. Third order you will write p plus 1 p plus 2 by 3 factorial del cube yn. Fourth order p plus 1 p plus 2 p plus 3 divided by 3 factorial del 4 yn. So that is how you will write the terms up to which you are required, which will be up to the order you are required, which will be clear from the difference table. In this table we require up to the fourth order. You will once again have a look at the table, and then we need it up to fourth order. So we will write the formula up to where we need it. So now we have chosen the values. This is the last value we have picked, 8, the last in the first order column. second order difference, the last value, the last in the third, the only and the last, whatever you say, because it has only one, fourth order has only one value, so it will be minus 3. So once again, if I show you, you will once again go back and I will show you that how it is. This value is picked from here, 101. This 8 is picked from here. This minus 4 is picked from here. Minus 1 is picked from here. Minus 3 is picked from here. So the end values in the concerning columns are picked. Irrespective, here it is written delta. It when we pick the end value, the numerical value will remain always remain the same. But notation wise, it will make some difference. But notation wise, it could make difference, but numerical value will remain the same. So we are going to pick it from the bottom we are going to pick, okay, and substitute in the formula that we have shown you. So value will be 100. So in this case we have used the Newton's backward interpolation formula, while in the first case we have used the Newton's forward interpolation formula, and that choice we have to make at our own in the examination, because it could be asked without mentioning the name that to calculate the values at these points, like here in the year 1895 and in the year 1930. It's 1930, so please make this correction. It's 1930. So please make this correction. It is 1930. So in this lecture we have studied how to choose, how to pick the right formula to calculate or interpolate the value of the function at the given value. If it is laying near the beginning of the table, then we are more accurate in selecting the Newton's forward interpolation formula, and if it is laying near the end of the table, then uh, we are fine in selecting the Newton's backward interpolation formula. So in this numerical example, which is very important example, we have discriminated, we have shown you how to select and apply the suitable formula under the given circumstances. So, and based upon the today's lecture knowledge, you could easily solve further questions in the field uh, where you will be asked to find the interpolated value at the any number of points. Then you will pick and choose the right formula, and then you will write whatever the calculation are required, and you will use the calculator if you require, and then reach at the final answer. So right formula in the right situation is the key to get the correct answer and get the full marks in the examination, and that will also create a kind of thinking, a kind of curiosity, a kind of the this kind of feeling that you have discovered something. So kind of feeling of discovery that creates. So you must understand the difference between these two. So that is all from this lecture. In today's lecture we have studied precisely that how to differentiate between the Newton's forward interpolation formula and Newton's backward interpolation formula, and which formula will be right in which situation, that we have illustrated with this example. And I hope that based upon this example you will solve the exercise problems given in your book, and if you feel any problem then you will consult me, and if I feel necessity I will create a YouTube lecture or create a video lecture on the same problem. So this lecture is must, and you thoroughly go through this lecture and gain the particular knowledge. So that is all I have from this lecture, and very soon I will be with you with my next video lecture. And till then, keep studying, keep working hard, and always concentrated upon your goal, and never ever have your target miss from the your goal. It has to be up to the mark, it has to be directly upon the goal, your target has to be spot on. So keep it spot on and keep working, and I will see you soon in the next video lecture. Till then, take care, bye bye, see you soon. This is Dr. Rajesh saying goodbye, take care, bye.